But indeed, I will present today about OR in the food system and like talk a bit about the different choices that we have. And before I go into the choices, I want to talk a little bit about the different pressures that the food system currently is facing. Because in fact, it's a quite dynamic environment and there's lots of different concerns that are arising. I mean, the title of the presentation already talked a little bit about sustainability. If we talk about sustainability, there's different aspects to it. One of those pressures is definitely an environmental pressure that we see more and more within the food system, because food, on the one hand, has a large environmental impact in terms of CO2 emissions and so on. Like agriculture is quite a big contributor, but at the same time, food's one of the industries that's largely affected also by those environmental like aspects like climate change and so on, right? We face more droughts and that clearly has an impact on our food production. At the same time, well, we see more and more concerns related to health of people as well, which has clear links with food because like people's diet and so on. There's like an increasing trend of diabetes and non-communicable diseases. So that's also an important pressure to consider, and also like in the context of sustainability, something important because it clearly sort of covers this the social aspect of sustainability as well. If we move away from, well, maybe not quite sustainability yet, but like if we look more at like the consumer side of things, we also have changing preference actually, because, well, on the one hand, there is more of like an awareness related to sustainability. So people want to make sustainable choices and so on. But at the same time, there's changes in consumer preferences for other reasons, which relates more potentially to population growth, urbanization. Our lifestyles are changing. So with these trends, we have different preferences because potentially I don't necessarily go to the supermarket anymore, but I have my groceries delivered, and like that's a preference, that's a choice that's impacting the system. And lastly, one of the pressures that we see is that despite all of those sustainability considerations and so on, we still have a lot of waste that's occurring in the system. And ideally, in order to sort of address these other aspects with like, we have a growing population that needs to be fed in the years to come, and like we have all those environmental pressures, we would like to reduce the waste as much as possible and make better use of our resources. So these are sort of the main pressures that we would like to address in the system. And now I would like to look a little bit into what is the system actually, or what are the different choices that we are facing within the system. And so I'm just gonna like walk a little bit like through the system. So we start with agricultural production. Okay, so there we have a lot of like fun little like logistics problems, decisions to make. We can like look into this a little bit more in detail later on. Then after that, we have first mile logistics. So how do we transport things from agricultural production to the next stage, which is the further distribution? We have global food networks, so we need to sort of link those things together from like the farm here in Quebec to wherever like the grain is going. Then we can talk about last mile logistics. This is like all this like inner city distribution, getting things really to the consumer, connecting things. Then we have consumption choices that we can try to optimize. That relates also to like the products that we consume. What type of products do we want to have? And all of like looking at all these different aspects in the system, we always have, again, waste and side streams and reverse flows that we can sort of optimize and try to make better use of. So As I said already, I promise you I will talk a little bit more about agricultural logistics and like the agricultural phase, or each of those phases that I just mentioned. If we look at the agricultural phase, there's actually like very nice, interesting problems that haven't been studied yet very extensively, and they become more and more interesting the more we think sustainably. Okay, so the idea what we want to look at there's a lot of monocropping that we do currently, and a lot of like pesticides, fertilizer usage, and all of that very, very bad for the environment. So the decision problems that I'm looking at with some of my PhD students currently is actually how can we optimize field management and planning? What can we do to sort of like have more biodiversity, like a better soil health, which potentially even leads to like better yield and so on. Potentially we can also consider like the crop interaction. So we have mixed cropping systems where we grow several plants at the same time, and they affect each other. Okay, and through that I can ensure a higher level of biodiversity and so on. Within these type of like problems, we can like focus on crop selection choices. So what type of like crops do I want to plant in my field? We can like consider crop management. So those are like related to all those operations that we have in the field. And there's a lot of different things we can think of. So there's a few examples. So we have, of course, like sowing and planting operations. We have nutrient management. What does that mean on a farm? It's basically related to like fertilizer and like the nutrients that are in the soil. So potentially if that also can relate to the crop selection phase, where if I actually manage to select crops in a certain way that they would help each other out within the soil and like give each other like nutrients or not take away from their nutrients, I need less fertilizer. Okay, so like this is something to consider. Then of course, harvesting choices. When do I harvest something? There's a lot of uncertainty involved related to weather, also like other factors like pests and so on. There would be pest management as well that I could consider. And all of those things are depending a bit on like my inputs, like the technology that I consider, the machines that I use. If you guys think about the like precision farming, I feel like maybe that's something you may have heard of. It's changing the way we operate in the field, right? Because we can, like the idea of precision farming is to really treat certain spots within the field separately and not just like apply fertilizer all over. And this leads to actually more interesting decision problems than if I just like run one machine over the whole field, as well as like if I have different plants, I need different machinery. I have lots of different operations that I need to consider. Okay, so it becomes quite fun in terms of optimization decision problems. And then also like related to this machine, we can also consider sort of in-field logistics and how these machines, drones, robots that we have actually move through the field and like operate their tasks that they need to do. So once we have addressed the whole like agricultural problem, there's, as I already hinted at before, there's a next step within the food system that we can consider, which are the post-harvest activities. And that's what relates to all those first mile logistics and also a bit like short chains. I'm sure you have heard of short chains. It's the sort of like we're trying to consume more locally and like eat local products, local food, support the local economy. It's a big trend within sustainability. The question here is it always better to consume locally? Does it make sense? What are the challenges in this context? And also like how do agricultural production practices, so what we've seen just before within the system, so like all these different setups, if I put more different crops within the field, how does this affect this part of the system? okay? Because like I have lower production volumes of one specific crop potentially, which may affect my storage. It also affects value-adding activities that I need to consider because like I have, again, a variety of crops that I need to treat. So there's cleaning, sorting, trimming, all those type of processes that may play a role. And then, of course, how do I transport things from the farm to those processing facilities or like further like in the chain. And in this transportation context, one of the things that is also very interesting to investigate is like, in particular, if I have smaller like volumes, because I'm no longer producing in this large scale, very intensive farming way, which is very harmful for the environment, how do I actually do the transportation? And there's like a lot of like interesting things that we can think of in terms of collaboration between farmers. Okay, so let's say we have several farmers that have a very small amount of potatoes that they produce because they produce potatoes and cabbage and onions and whatever other crop, but like of every plant only a small amount, then it doesn't make sense for me, or maybe I don't have enough of a quantity to fully like fill up a big tractor with a container at the back, but I need to sort of like collect things like at different farms to actually bring it to my processing facility. And like, how can we make this collaboration work? So far, like I've looked a little bit into this, but like hopefully we're gonna do some more fun future research on this starting in fall with a PhD student. If anybody is not doing a PhD just yet or wants to change their topic, give me a call. I'm hiring. This is in the Netherlands though, but yeah, I'm hiring. So, and then another thing that we can, next stage that we can consider is the further distribution and processing. Okay, so this is really like large global scale. Why is this important? Well, it links a little bit again to consumer preferences, right? We don't just necessarily want to like eat what we produce here in Quebec. That would maybe get a bit boring. Also very difficult in winter. So it's good to have products flowing in from other countries. And in food, like the thing is like products don't necessarily grow everywhere. So I need to have those global chains to bring one product from like one place to another place. Again, there's these seasonal aspects that I can't grow everything at all times everywhere. So I can sort of consider here also from a sustainability perspective, when does it make sense to get things from one country or from another country? Like what's the impact of producing something in one country or in another country, right? Like, I mean, if I produce tomatoes here in Quebec, I might do this in a greenhouse. If I produce them somewhere in Mexico, I produce them in a field, which has a very different environmental profile because like my resource input will be very different. In a greenhouse, I need to use energy to heat the greenhouse. If I do this like somewhere outdoors in a field and like I can use the solar energy of the sun, I don't have that resource input, but potentially I need to irrigate more and I have more water use and all these type of things. So it's interesting to consider and sort of like see how these choices affect the system and like also like how consumption plays a role. And this is basically what I've done like during my PhD, and these articles that you've seen here is really like, what's a sustainable supply chain design, looking at this like global level and like the different choices that are involved, and like how do different consumption patterns actually influence the underlying system? How does that change the setup? So if you are interested in that, like check it out. It was quite fun to do. It also shows that like, well, it's better to eat less meat and so on. So it's maybe something that you already know, but like the other thing is what's interesting to consider here is the different indicators again. Like we were talking about this aspect of energy versus water use versus land use and so on. Like, and we actually see a lot of trade-offs between these type of like objectives that we can consider. So like it's not always better to have this, there's not always a clear path that we can follow, but we have to sort of like, well, evaluate the different aspects and then still make a sort of compromise choice, which is an interesting aspect to also see. It's not usually straightforward when we talk about sustainable choices. Moving on to the next part in the chain, we move to last mile logistics, which I think within the Sorel-Girard environment is probably something that you definitely have heard of. So last mile logistics can actually like mean a lot of different things within food or overall. There are a lot of like innovative concepts that are popping up on like how do we get things to the consumer, a lot of different like business models that are being tried out. So like if we look at these different type of distribution channels, probably the most common one that we still use to connect our products to or our production site to the consumers are supermarkets or farmers market or markets overall. And there's many things that we can also still optimize. And this is very related also to waste and inventory management, how that you can see that there's a lot of like work in that area. How do we sort of like manage waste or minimize waste at the retail level? So actually a very recently published paper, I'm advertising my work today here. This is great for visibility. With a friend of mine, we actually focused on something that we call inventory dynamics at the retailer, sort of trying to explore what is the impact of packaging at that stage. So like packaging, we always talk about is bad, but there are also other positive aspects of packaging. And how can we optimize our decisions at the retailer, or maybe not optimize, but what's the impact? It was more of it's a simulation model where we sort of like try to evaluate the effect of different inventory policies and packaging at the retailer. Another thing that we can look at in last mile logistics and distribution channels is really like routing. Okay, I guess you all know about what routing problems are, but yeah, there's a lot of last mile delivery routing problems that are popping up because, like, again, so many different innovative approaches that we can look at. It gets more fun if we consider food because it then becomes perishable products, and we kind of like see there's decay and like how does this change our setup of the system. Okay, another article here that I've worked on during my PhD to sort of like try and set up that system, considering delivery patterns, which is quite common within grocery deliveries. And then last but not least, there's like also like all these innovative like new consolidation solutions where we talk about like pickup points, which is a sort of new way to be in between the supermarkets and the home delivery. So I don't necessarily have all the struggles of home delivery with time windows and all these type of things. But my consumers can conveniently go to these pickup points and actually pick up their food whenever this is most suitable for them. And well, while I haven't really done so much in this context in the food system, there's like, I've worked on a little bit of an overview on what are actually like the challenges related to parcel lockers in that area and what are the decision problems in that context. So, and then the last stage in the system is consumption, okay? Consumption, for me, basically in this context is product choices. And how does that change with sustainable decision making? Well, there's a growing consumer awareness, as I already mentioned before. So that means consumers generally want to make healthier choices, and they start taking into account like environmental considerations, okay? So how can we design products that actually sort of like take these aspects into account and are both healthy, but also like better for the environment? Okay, considering also like all the constraints that I have related to a certain product, okay? And then we see also like in that context, we see a shift in consumption patterns, okay? So what like we have, at least within this like sustainable realm, a sort of movement towards more plant-based consumption because we sort of know that meat's bad for the environment, okay? And another thing is like, again, related to this like local consumption. Like ideally we want to use local ingredients, local product. How does this affect the products that we're creating, the design of our product? So, and then like from this, do we need to rethink the system or just like certain choices, certain products, okay? So in this area, I actually like had a fun little project with a master's student that I supervised during my PhD, where we actually looked into the design of a meat replacer and how can we design sort of like burger patty that has an equivalent nutritional value to meat, whether that is beef or chicken. So like we can optimize for both, but that has a lower environmental impact, okay? And like we actually like developed a sort of easy little like model, like very like straightforward linear programming model where that gave us different options where we considered, okay, what if we have an equivalent like to beef or to chicken using only like plant-based ingredients, so like a vegan option, or where we can also use potentially some dairy products, or even considering, okay, well, insects are a trend now. How would this look like if we throw some insects in the mix, and like what's the environmental impact? So there's lots of things we can do here also in terms of like optimization and so on to evaluate these type of choices. And then the last aspect of the system that we can consider is, okay, waste. And like, how does this play a role? As I said, there's a lot of like waste side streams and reverse flows that we want to make better use of. How can we do this? And their quality plays a big role within the system. And ideally, we want to, depending on the quality that we have, we ideally want to make the most use of a certain option, okay? Most use usually means if I can consume it directly, I want to consume it directly, right? Because everything else needs further processing, needs further resource input, which potentially actually makes the environmental impact worse. So it's also about like this idea here is sort of, is it always better to do something with the waste that we have, or is it maybe sometimes better to just leave it and not do anything with it? Okay, so in this context, I actually have a project with a PhD student of mine where we are currently looking a bit into also the agricultural stage, but like there's a lot of like waste and return flows at that stage where we leave products on the field or we don't use like the full product, even though it is edible. So like, for example, we have here cutting and trims of a cauliflower. That's usually just chopped off at the field and left on the field, but it's edible. We could use it. We could put it into like a chopped up stir fry sort of mix in the supermarket. Can we gain some value from this? Does it make sense or not? Also, like if you consider beetroots or something like this, I can eat the beetroot itself, but I can also like do something with the leaves. Actually, they have often quite a a good value, like I can sell them through like different like supermarkets, like sustainable supermarkets, sell them at a quite high price. So can I still gain an economic value out of this, but also like make better use of the product itself? So that's a bit what we're exploring here. Another thing that I'm currently actually involved is then like more on this like food redistribution level, where I work with some colleagues of mine from Tilburg University on the redistribution of food banks. And then we face like fun little routing problems again that gets quite complex, because one of those issues with waste side streams and reverse flows is that there's lots of uncertainty involved that's hard to control, because, well, if I'm producing something, I can produce it in a way that like, well, I sort of like define the production quantity, right? Might have some losses and whatnot, but overall, I know the quantity that I produce. If I'm talking about waste or like side streams, it's not necessarily clear how much waste I will have, or like how many return flows I have to actually do something with. So uncertainty becomes an important like question in this context. So lots of interesting choices. How do we make them sustainable? There's 3 dimensions to sustainability that we can consider. The first one is an economic dimension. Economic dimensions are important because, well, the system still needs to be viable, okay? Like it doesn't make sense to have like an amazing choice from an environmental or a social perspective if like in the end, well, I cannot sustain that system from an economic like point of view. So like I still need to sort of like make a profit or at least cover my costs if I want to have this like going long term. However, this is like the most widely used objective. Like if we talk about any optimization model, we usually look at costs or we look at profits, okay? Just covers like the costs of all the different components in the system, gets a bit boring, and it's not necessarily good for the environment. So next choice that we have, or the next sort of aspect that we want to consider when we talk about sustainability, and that's also what we see in the literature, is environmental aspects. The most often, like I think this is most often done talking about greenhouse gas emissions. Okay, like if you look at any like sort of sustainable like modeling, literature, optimization, whatever, usually they try to optimize CO2 emissions. It's very much in line with costs in a lot of cases. It's not super interesting. I mean, it's still good to do, but the fun thing when we actually look at sustainable choices is looking at different indicators, because then we see that from an environmental perspective, there's actually lots of things that are happening at the same time. And like just reducing emissions doesn't necessarily mean that it's like it doesn't have any negative impact on the environment anymore. Again, if we look at agriculture, I may be reducing emissions by like going and like putting plants in a field in Spain, and instead of doing this in like the Netherlands, because I don't have to like heat my greenhouse. But at the same time, maybe I need to use a lot more water in a region that doesn't have a lot of water, which again also has an impact on the environment, right? So like there are lots of other things that I consider and that are super relevant, in particular when we talk about food and agriculture. And there, what is interesting is to sort of explore what are those trade-offs and how can I potentially still find good solutions considering these trade-offs. And then the last, well, dimension within sustainability is the social dimension, which you don't find so much in the literature if you look into it. The reason for this is because it's often really hard to measure and aggregate and also quantify. Like, how do I aggregate social welfare across like a global network? It's just like, or it's at least super hard to optimize, like being like, oh, okay, like I just want the system to be good, but like, then I need to sort of like look at equity and all those type of things, and that gets quite challenging, quite difficult. And also like finding good indicators that actually make sense, that I can easily quantify. So it's a bit challenging. What we have done in this one like global sort of like paper that I did, like my PhD, is like sort of identify health as a social component, and like in food that sort of made sense. So how can I actually like still guarantee a good healthy diet within my system and so on? But it's not very straightforward. So if you have any good ideas there, contact me and we can do something. So now looking at all those choices and like the different dimensions, there are a lot of factors which I've already partially touched upon that influence the system. And one of those important factors are external factors or regional characteristics that I'm facing. So that means climate, which is very important from a food perspective, because like in particular, if we talk agriculture, it has a huge impact on also like the inputs that I need, the sustainability profile of a product. Another thing is geographical conditions and distances, okay? How far do I need to transport things? Because maybe only grows in one region and I need to like travel like all this distance, or like there's other aspects like it's perishable products, right? So like if I have long distances that I need to travel, then that will affect the quality of my product. So this is something that I need to consider within food. And also potentially like if I have bumpy roads like you see in that picture there, and I'm traveling on those roads, that might also have an impact on the quality of my products because they get bruises and cuts and whatever from the transportation. So in that context, it also plays a role what sort of resources and infrastructure do I have available within a certain region? Or is there water scarcity? What are my soil conditions if I talk about agriculture? What is the nutrient profile that's already available in the soil? So all of those things are aspects that I should be taking into account when I look more at like a transportation distribution perspective. Is like, are there port infrastructures? Are there like what type of energy mix is available within a certain country? Okay. What are the volumes and the demand that I have within a certain country? Because volumes, we can talk about like consolidation. If I have small volumes, if I have big volumes that I'm like need to transport, then like potentially I'm already filling like my capacity in quite a good way. It's already quite efficient transportation. What type of demand do I have? And what are the policies in the regulatory environment within the region that I'm operating? Is there certain constraints that I need to consider for a specific region or for a specific problem? And all of those aspects that I just mentioned basically affect my system requirements and my inputs. So these are resource requirements and resource inputs, which affect production, transportation, and storage. And then another thing that like I can consider in that context is the technology that I use. Okay, so that's the equipment and mode choices. So do I use electric vehicles? Do I use drones? Do I use big trucks? All of that will change my decisions. Potentially it is a decision within that problem. And also like what type of technology do I use in production and processing activities? Do I need a lot of energy for that? Is that like very water intensive, like from a production perspective? So all of that will affect the sustainability of my product or my production. And potentially it will affect the quality change, because potentially I can choose certain technology that actually is better for like from a quality perspective, right? Like the handling equipment that I will use will potentially be, well, better because like it's less bumpy on the road, and then like I don't have those cuts and bruises that I was talking about, or whether if I use cold chain technology, then like I can sort of like prolong the shelf life of my product. So like lots of different like things that like can impact the quality. Usually when we talk about quality in food, or in the literature, in routing as well and so on, we talk about quality decrease and waste, because it's a very important aspect from a sustainability perspective. There we can model this in different ways. There's different models for that. There's microbial growth models. There's all these like bruising and softening aspects that would happen like just using certain transport options. So then it's potentially more of a percentage that like we can take into account that would happen. So there's gradual exponential decay as well. So it's like something that decays over time. That's normal for food, right? Like a banana will sort of like ripen until it's no longer good. And there's shelf life, right? If I consider milk, dairy, meat, whatnot, at some point it's just no longer, there's a best before date. And like, I don't want to consume it afterwards. Before, I don't necessarily care so much what's the stage of that product. So it's just like, it's good until a certain date, and then I don't want to consume it. So all of those type of things have been considered in the literature quite a bit. One thing that's a bit less addressed, but that's also very interesting in food, is quality increase, because we actually have ameliorating product. Okay, we see that in agriculture, but we also have other examples of products like cheese, for example, is a product that ages over time. Another product is whiskey, wine, all of those sort of like luxury products that many of us consume. They actually ripe or age, or if we consider fruits and vegetables, they grow, and like we can get different prices for these products, right? So the question there then is like, for these type of things, how long do I keep my things in inventory, whether that's in a field, whether that's in an aging room where I ripe my cheese, like how long do I keep those products there, potentially also considering that there may still be losses that occur at the same time. I have to keep putting in more resources because, well, first of all, there's a financial component to keeping things within storage, but also potentially I need to cool the room. I need to like invest in other things like new sort of like inputs that I need to consider. So have a little like project there as well, which was published last year on the inventory decisions for ameliorating product under consideration of stochastic demand. So that's actually focused on whiskey and cheese. So sort of like investing a bit what happens if we don't have hay necessarily. And then the last thing is, the last important factor that I want to consider here is packaging. So packaging, often considered very bad. However, packaging also has functions that we actually like for product, okay? So there's a protective function, there's a shelf life extension that comes with packaging, there's information sharing that is sort of provided by packaging, and it also sort of like facilitates handling in some cases, right? It makes it easier. So it's not necessarily a bad thing, and it's also not necessarily a bad thing from a sustainability perspective, okay? So actually the paper that I was talking about before in terms of inventory dynamics at the retailer, we show that actually in some cases for some products that have a very short shelf life and where like the shelf life extension from packaging is quite big, we actually see a positive effect in terms of the environmental impact if we package products. Okay, so it's better to buy like a cucumber wrapped in cling film because the environmental impact of the packaging is marginal in comparison to what we would have from the waste of the cucumber. Okay, so it's quite interesting to consider as well. And then there we have choices in terms of like what type of packaging can we use, lots of different like trends that are kind of like happening there in terms of biodegradable plastic and so on. And this again relates to the reverse flows and like all of like, how do we manage that? And like, what do we have in terms of waste and what's the environmental impact of this waste and so on. So very interesting to consider as well. And now I want to talk a little bit about some modeling actually and go into detail on some transportation related things now that you have that overview of what's happening. So this is a paper it's entitled Production Routing for Perishable Products. It's a project I did with friends. I assume some of you might have already heard about production routing. It's basically a sort of integrated supply chain planning. The idea of this integrated supply chain planning is to streamline operations and then sort of identify some efficiencies through that, which enables us to cut costs and increase our performance, okay? In this case, we've done it for perishable products because, well, I work on food and that sort of makes sense, but also because quality considerations make the whole thing a bit more interesting and exciting. So what we considered here is both value change and the shelf life. So again, I mentioned that like quality change can happen in different ways. Here it's really quality decrease, but a gradual decay and shelf life at the same time. And we sort of want to consider the storage times of products. What's the effect and like what happens? So the production routing problem, the idea from a general perspective is that it jointly optimizes this production and distribution decisions. So there's a production planning component. So that's lot sizing and inventory decisions that we need to make. So what, when, and how much do we produce or keep in stock? Ruff's the expert for that, if you have any questions. And there's like a distribution plan. That's the other component to the production routing problem, where we like need to define the delivery schedule, the quantities, and the routes that we want to like use. And there's actually been a growing attention in the scientific literature on these types of problems. However, not so much has been done on perishable products. There are a few references here at the side where people have focused actually on food and perishables. So the problem setting here is we have a single supplier which produces and distributes a perishable product. There's one plant with a storage facility. There's a limited production capacity, fixed and variable setup costs, and an inventory cost. So that's all at the production facility. And overall, we consider a multi-period planning horizon for the problem, okay? Now, if we look at the distribution side, we have a set of customer locations where the customer demands per period are known. So there's no uncertainty involved in this case. There's storage facilities at the customer locations. There's the site-dependent inventory cost and the limited capacity at each of those locations. Then we actually consider transshipments, because sometimes this can happen within grocery retail that products are redistributed from one supermarket to another. And these transshipments basically incur a cost per unit of product shipped and can be used directly for demand fulfillment, okay? So if you consider with an inner city environment, you ship from one supermarket sold out of the specific type of yogurt, the one like a few streets back from the same like supermarket chain still has them, it's not selling at the same rate. So potentially we can like move between these locations, okay? And there's a homogeneous fleet of vehicles that we consider with limited capacity, and like all of those like start and end their routes at the production plant. Now, with regards to the product is perishable in nature, has a fixed shelf life and a gradual decay in product quality. So that means in this problem, we have an age-dependent pricing, and actually demands can be satisfied with products of different ages. So we don't necessarily assume that anybody has like a specific demand for a certain age or not. So the decisions are then when and how much to produce during the planning horizon, when and how much to deliver to the customer locations, what is the optimal routing of vehicles for the different time periods, and when and how much to transship between the customer locations. Okay, and then how do we satisfy the customer demands, taking into account the different product ages? Okay, so this is, well, part of the model. There'd be more. So we have an objective function, which is a profit maximization, which is basically the total revenue minus the total cost. We have some inventory constraints, both at the plant and at the customer locations, and we have some customer demand satisfaction. At the same time, we have the capacity constraints for production, storage, and the vehicles, and we have some logical constraints. So there's a flow conservation, subtree elimination constraint, and like the visit. So it's just to make sense of all of it, that it still works in practice and doesn't do any weird things. And for this, we then propose the hybrid heuristic algorithm, where we start with a construction heuristic where we sort of solve a reduced version of the MILT model that I just showed you, which excludes the routing decision and only approximates the distribution costs. And then from that, we basically solve a hybrid genetic search, which was proposed by Thibaut Vidal, to solve the routing part. Okay. After that, we have two local search variants that like try to optimize the initial solution, where the first variant is aimed at improving the delivery routes, and the second one is aimed at improving the visit decisions. And then we have a perturbation component, which focuses actually on the production setup and the customer visits. Okay, so it just tries to perturb the solution that we have obtained. And after this, we solved a reduced LP formulation to determine the continuous variables. Okay, so that's all the production and delivery quantities, the consumption amounts, and the inventory. Okay, whereas the one before is like just like setting the production setup and customer visits. So when do we actually deliver, like given this like planning horizon? And then in the end, we have a MIP-based local search where we just like insert and remove like customers from routes to again improve our solution. So we tested this on some instances which have been adapted from the instances proposed by Adil Yasak for the standard PRP. We added some assumptions so that we have a maximum age, an initial price and value decrease, well, we added a transshipment cost, and which is basically a sort of weighted travel cost that we consider. From a managerial insight perspective, we see that transshipments are great because they increase the profit of the solution. So from a financial perspective, that's good news. At the same time, we see that these transshipments basically allow us to manage our inventory at the customer level, so like at the supermarket level, more efficiently, because I'm able to sort of like, in particular, because we have those like perishable products, right? I'm able to transship products that are already more aged to another customer that like has the demand, rather than like, and like it shortens the distance in terms of distribution costs. And so I have actually economies at the routing level, because I have to do like less routes. I can just like transship and make better use of my inventory capacities at the customer. So that's good news. And like, basically what we see is that we overall reduce the inventory quantities that we keep at the customer locations. because we, again, use the available inventory better and we have less waste. Okay, so that's nice. So there's a reduction of storage, like of old products, and the proportion of fresh products increases because I start using like the old product earlier rather than keeping it at my inventory at the customer level. Another thing that we see if we look at perishability is that actually all types of perishability lead to increase in the cost, okay, which makes sense because basically it's modeled as like as the quality goes down, I get less profit for like this, and like so I have a reduction in the overall profit, and I need to ship more products because I want to like have higher revenue. At the same time, like at some point there's a shelf life and like products go to waste and so on. So I need to sort of like put out fresher products. So I need to produce more and I need to ship more often. At the same time, we see that perishable products are usually sold faster because, well, they spend less time in storage than the others. So our inventory cost actually decreases. The revenue overall remains unaffected if I consider a fixed shelf life, because then we don't have this like profit decline because there's no gradual decay. Profit margins decrease more quickly with higher rates of decay. That makes also more sense because like our profit is directly related to the decay of product. And yeah, so higher rates of decay also increase travel and production costs. So because we have smaller batches and more frequent deliveries. And this is my last slide. So from like the last thing that we wanted to do is also to show that like the modeling made sense, and our computational analysis actually showed that our heuristic first outperformed CPLEX for the perishable case. So, well, yay, that's good. And when we actually compared it to the performance of the state-of-the-art solution methods from the PRP literature, we're also still finding good quality solution within a relatively short running time. So that's also very nice, even though our heuristic wasn't designed for those instances, but we can still see that we're performing well enough. As I said, this was my last slide. Thank you for your attention.